Hello all, welcome to Excel Academy. Today we are going to continue with the same topic, that is properties of system problems. Okay, so today let's see two problems with respect to continuous time. Okay, so it is like with respect to t, we are going to see two problems today. So the very first problem would be, that is y of t is equal to dx of t by dt. Okay, so I'll also show you the textbook, along with I'll also going to do solve that particular question. Fine. So let me write here, that is y of t is equal to it is dx of t. Yes, it's dx of t by dt, right? Just a second. Yes. So now, we are going to do the transformation of, that is ax, that is whole transformation of, that is what? That is ax1 of t plus bx2 of t, right? Yes. So now, for the whole transformation of ax1 of t plus bx2 of t, so what is that resultant you are going to get? That resultant you are going to get, that would be like, that is, you get it as your d by dt comes in outside. So your d by dt comes outside, and your resultant would be, that is, your ax1 of t plus bx2 of t. Right? Yes. So here see, you can see that. So what is that going to happen is, when you take the transformation of ax1 of t plus bx2 of t, that is when you apply ax1 of t plus bx2 of t into the system. So what is the resultant is, as the resultant is a differentiation system, so you are going to get it as d by dt, that is d by dt of this particular system. Right, d by dt of this particular system that you're given, that particular input that you're given as a system. Right, this is what is the input that you're given to a system, and as the system was the differentiation system, this differentiation, what happened, this differentiation came outside and it became differentiation of this particular input. Right, so this differentiation can be multiplied to this. I already told you, right? So what I told you, whatever, if you get an equation like this, you need to see that whatever the thing which is outside, so this d by dt is outside for us now. Whatever is outside, if that gets multiplied to this ax1 of t as well as bx2 of t, if it does not get multiplied, then I told that it is a non-linear system, right? Sometimes you can tell by seeing the question also. In the question also, what happens is, they will provide like sin x of t, cos x of t, log x of t. I told you those things are non-linear system, because you get sine of this particular ax1 of t plus bx2 of t, wherein that sine cannot be multiplied to what? That sine cannot be multiplied to this ax1 of t as well as bx2 of t, because it becomes sine of that system. And if you get some like a tx of t or tx of t, for those questions, what happened, you can multiply t to this particular x1 of t plus bx2 of t, right? Yes. So that is why what you have to do is, you need to see through that first. Like whatever you get an expression other than x of t, you are going to see if that gets multiplied to this particular ax1 of t plus bx2 of t in the case of the whole transformation. So you can see that, so it is a linear system, or else it is a non-linear system. Okay, so now expression in the sense like apart from x of t, if you got any other multiply to x of t, any other things, for example tx of t, so your t is multiplied to what? I can say that your t is multiplied to the x of t, right? And if I say sin x of t, so what is sin x of t? I can say that sin is multiplied to x of t. So sin is associated with x of t. Like that. Those things you have to see. The things which are associated with x of t, you need to see that, and you need to make sure that things get multiplied to the ax1 of t plus bx2 of t in the case of whole transformations, right? Yes. If not, it is a non-linear system, right? Yes. Now if I coming on to the, that is A transformation of x1 of t plus B transformation of x2 of t. So what is that I get the resultant? My resultant would be what? my resultant would be, that is, you are going to get it as, that is a, that is d by dt of x1 of t, right? Yes, correct. Yes. So now plus b into, that is d by dt of, that is what, x2 of t. So b is a constant, so you're going to keep it aside like this. So this is also a, you're keeping it like this. So here all this is equal to this, right? So here I haven't written this one again, so you're going to write the same thing here. I told you, right, d by dt gets multiplied to the this thing, ax1 of t and bx2 of t. So I write it as a into d by dt of x1 of t plus b into d by dt of, that is x2 of t, right? Yes. So this is what I can say, that it is a linear system, right? I guess you all got it. Yes. So what is the thing here? The thing here is, I told you that whatever the things that is associated with x of t, or whatever that is multiplied to x of t, you need to check with that if that gets multiplied to this ax1 of t plus bx2 of t. That is what the whole transformation, that is this one, right? By seeing the question only you can tell sometimes, because say tx of t, can directly say that it's linear. Sin x of t, you can directly say that it is non-linear. Log of x of t or log x of n, you can say that it is non-linear. And cos also non-linear, as well as your log 10 of x of t is also non-linear, or exponential is also non-linear. So like that you can tell. But sometimes for the questions like this, wherein you cannot get to know by seeing the question itself, do this process first, and you have kept the d by dt. Now you have not kept d by dt outside. What is that happens is, when you apply x1 of t plus bx2 of t to the system, so as this is a differentiation system, it is going to result in differentiation of this particular input, that is ax1 of t plus bx2 of t. And then what you have to do, you have to check through that whether this differentiation, then you have to see that if this differentiation gets multiplied to, that is your ax1 of t as well as bx2 of t. If so it gets multiplied, so then you can say that what, it is a linear system, because when it gets multiplied to this, you get the result like this, right? d by dt. So now when this differentiation gets multiplied to ax1 of t as well as bx2 of t, so then my resultant would be like this, that is a into dx1 of t by dt plus b into dx2 of t by dt, right? So now what is that going to happen is, when you take the separated transformation of x1 of t as well as x2 of t, you get d by dt of x1 of t as well as d by dt of x2 of t, right? So along with this a and b, that is the constant values. So now we can see that this and this, that is the whole transformation of ax1 of t plus bx2 of t, as well as the a transformation of x1 of t plus a b transformation of x2 of t is the same, right? So that is why I say that it is a linear system, right? I guess you got it. So you need to make sure that whatever that is outside this thing, like this kind, you might get any others also, not only the differentiation. You have seen many others also, like sine, cos, what I can say, the logarithmic, or any other t, or any other you've got like this, right? Variables, or sometimes sine, cos, tan, or sometimes your what I can say, logarithmic and exponential, so and so you've got. So you need to make sure that that should get multiplied to this too, because when you do single transformation, you get that like this, like in the sense, in the case of single transformation, if you take for tx of, for sin x of t only, if you consider, you get sin of x1 of t plus sin of x2 of t here, right? This is sin of x2 of t. This one would be sin of x1 of t. Here you get sin of this whole, but sin cannot be multiplied, right? So it becomes different. So when this particular gets multiplied to this, and in the separate transformation, when you get this particular along with x1 of t, then both becomes the same. That is why I told you. I guess you got it right. So this got multiplied in this. So you got like this. That is d by dt of x1 of t. Here also you got right, d by dt of x1 of t. In the case of what? In the case of separate transformation, both becomes the same. When you multiply this to this, so you get the same over here, right? You get the same, both becomes the same. So that is why it's a linear system, right? I guess you got it. So now coming on to time invariant system. No. So now, in the case of time invariance system, I can say that, what I can say, that is a transformation of, that is x of t minus t naught will be is equal to what? That is y of t minus t naught, right? Y of t minus t naught, right? Yes. So now, if I consider the transformation of x of t minus t naught, what you have to do is, wherever you find t, you are going to subtract with minus t naught. So my question is like dx of t by dt, right? Yes. So this you can say that it is a time invariant because you have only one t, right? Here what happens for the transformation of x of t minus t naught, it would be that is dx of t minus t naught divided by dt, right? Yes, yes. So now coming on to my y of t minus t naught, so what is that going to happen is, so that is you get it as, that is dx of t minus t naught. Now t is replaced by t minus t naught. That is what? That is divided by your dt, right? So now this two becomes the same, and so therefore it is a time invariant system. What? It is a time invariant system, right? Yes. So you need to make sure that you understand the concepts clearly well, right? In the case of time invariance, what I have told you, I have told you that if you find more than one t, which is not, that t should not be associated with this x, like that should be outside. Like I told you, tx of t here, and you, for example, that is e to the power of n into x of n, so and so kinds of questions. You have an n which is not associated with what? That is your, what I can say, the x, right? So those kinds of questions are non-linear system. You need to have more than one t, but the other t, that is the second t or third t which is associated, which is present, that should be not associated with this x. Like you might not get questions like x of t into x of t minus 1. Here t is associated with x itself. So when you see that in the case of transformation of x of t minus t naught, you can substitute for this t also you can subtract with minus t naught. For this t also you can subtract with minus t naught. So therefore both becomes the same. When you take y of t minus t naught also, you get the same result. But in the case of tx of t, what happens? You neglect this t for transformation of x of t minus t naught, and what you do is you just take this particular t into consideration and you just subtract with minus t naught, right? This is what is the same thing, right? This is what is the thing. And when you take y of t minus t naught, you consider this t also there and you do t minus t naught. The resultant would be like t minus t naught x of t minus t naught. There it is tx of t minus t naught, and both becomes different. So it is a time variant system. So therefore you need to find a question like this. By seeing the question only, you can judge sometime whether the system is linear, time invariant, memoryless, causal and stable, right? Yes. So that is what I told you. You need to check a t which is not associated with this x. Like it might be a single t. Like it should be a single t. Only a single t, or t plus 10 or t plus y, like that. It should be a single t, but it should not be associated with this x like this. That is x of t or x of t minus 1. So and so it should not be associated, right? I guess you got it. So now coming on to memoryless concept. Memory concept. So in the case of memory concept, so they're taking one into condition. What is that condition? that is x of t is equal to t for, that is your t is what I can say, the greater than or equal to greater, right? Yes, greater than or equal to 0, and they're telling that is 0 for t is less than 0, right? What is this condition? This condition is somewhat equal to what I can say, the unit step function, right? Because for t is greater than or equal to 0, it is 1. But here he is telling that it is t. Like for example, if you take t is equal to 1, if your 1 is lesser than or equal to 0, what I can say, the answer would be equal to 1 itself. That is whatever the t you have considered, right? Yes. So now here this is 0 for t less than 0. You know that in unit step function it is only for positive part and it's not for negative part. For all the negative time period it is 0. For all the positive time period it is 1. Right? I guess you already know that, and it is the same kind of condition only, but is telling that the x of t, that is the amplitude, would be is equal to t. It is not 1. Right? Amplitude is not 1 here, but the amplitude is t. That is whatever the t you consider, if that t value is greater than or equal to 0, then he says that the amplitude would be a t value that you have considered itself. Right? Yes. So by this condition you can see that for your y of t, that is equal to dx of t by dt, that is your given question, right? For dx of t by dt, so you can see that, so that is what? You can see that, what I can say, that is, it would be 1 for t greater than or equal to 0 and 0 for t lesser than 0, right? Yes. So now, you can see that here he is telling that it is 1 for t greater than 0, that is 0 for t less than 0, right? Here 0 is not considered because it is not equal to, that is being given here. It is only greater than, right? Yes. So now he is telling that whenever you substitute values of t, you get that for the t that is greater than 0. If you substitute any value of t here which is greater than 0, you get it as 1. That is the amplitude as 1. And then 0 for t less than 0. That is, you get your resultant as your unit step signal only. This condition is whole and sole for unit step signal condition, right? Yes. So for t greater than 0, you get it as, so that is 1. But here 0 is not considered. So it is somewhat equal to unit step. So see, in the case of unit step signal, I'll just show you. Just a second, guys. So you get it more clear. And yes, in the case of your unit step signal, that is, you can see that, let me show you in the continuous, yes, here. See, your unit step function is what? That is, t is greater than or equal to 0, isn't it? Here 0 is also considered, but that 0 is not considered. So therefore it is somewhat equal to your unit step only, right? Yes. So now, let's go on to that particular question now. So in that particular question, he is telling that you get y of t is equal to 1 for all, that is t that is greater than or equal, t that is greater than 0, and so therefore you can say that the system is not memoryless, right? Yes. And here one more thing, guys. Here he has left one this thing. What is that? Left greater than or equal to here. So I have to write it equal to here. I saw it now. So see, here is telling that y of t is equal to 1 for all t greater than or equal to 0 means here also it should be equal to symbol, right? Yes. So it is not given. So please do make sure that you write it. So he is telling that whatever the value substitute for t, so for that value of t you get it as 1 for those t which is greater than or equal to 0. That is, you substitute the value starting from 0 to infinity. If you substitute those values, you are getting the amplitude as 1. So therefore, for each and every time period, that is from 0 to infinity, or 1 is a past value, right? Only for 0 it is a future value. but for all others it's a past value, so therefore I can say that it is a not memoryless system. Okay, and one more thing, please do make sure, I told you that here it is equal symbol should be present, but no equal symbol, because here is telling that it's a causal system. I guess here only has made a mistake, I don't know, but somewhat it's fully confusing this part. But let me tell you, if you take t is greater than or equal to 0 as per has given, so what will happen is, so you consider even 0 also. So when you consider even 0 also, what's that going to happen? If you substitute 0 here, and for 0 if you get it as 1, so then what happens? For 0, 1 is a future value. For all others it is like your 1. For all others it is like your 1 is a past value. For 1 it is the same, but for all others, that is 2, 3, 4, 5, it is a past value, right? So for 0 it becomes future value. So then it should become causal, non-causal, right? But it is not. So therefore don't write this t is greater than or equal to 0. Just only write t is greater than 0. So therefore it becomes causal, right? Yes, that is why he has given here t is only greater than 0, because if you consider 0 also, then it would become non-causal, because in 0 it would be proved that for 0, 1 is a future value, so therefore it would become non-causal, but here it is not. So therefore it is only t is greater than 0, right? Yes. So here you can see for causality that the output does not depend upon future value, so therefore it is a causal system, right? Don't consider this greater than or equal to 0. I am repeatedly telling you, if you consider greater than or equal to 0, see, he is telling that y of t is equal to 1 for all values greater than or equal to 0, for all values of t greater than or equal to 0, right? If it's telling like that, so then what will happen? For t equal to 0 also, if you consider, you get the resultant as 1 amplitude. For 0, what is 1? 1 is a future value, right? So if 1 is a future value, then you can directly say that it is non-causal, because for 0, 1 is a future value. You can say that it's depending upon future value y of t, so I can say that it's non-causal, right? Yes, so to avoid that, so that is why it becomes wrong. So therefore whatever he has considered over here, please do take that into existence, and please do write that it is greater than 0 itself, right? So see here, yes. So this is causal system, and here he is assuming that the system is a unit step signal. X of t is u of t. So therefore your y of t will become equal to 2 times delta of t. That is, delta of t is your unit impulse function. So therefore this unit impulse function have unbounded amplitude. So therefore the system is unstable, right? So you are giving u of t as an input, and you are getting an output. That output is what? Delta of t into delta of t. So you are going to give, here is a system, right? Yes, I'll write a system. And in the case of the system, I apply u of t as an input to the system, that is bounded input, and I check with a y of t. So that is, I get it as 2 times of delta t, which is what is my impulse function, and this impulse function is an unbounded amplitude. So therefore it is unstable system, right? I guess you got it, right? So please do make sure that you understand the you get the answers by seeing the question itself, right? Like there is no need to, what I can say, just do the procedures, right? Like in the sense, you have to be mentally prepared in such a way that you, while seeing the question only, have to answer for that particular question, right? By seeing the question only, you need to say, oh, this question is linear, or this question is time variant, this question is memoryless. Like that you have to do. But for the case of examination, you need to do all this process, I know that, but you must be that much mentally prepared so that it would be easier for your examinations, right? Yes. So you must be that much talented to do it. That is why I told you what are the conditions wherein you find, if you find these conditions, you can easily say that it is a time invariant system or invariant system, linear or non-linear, memory or memoryless, causality or non-causality, stability or unstable. So I've already told you in the questions, right? In the last videos, right? So those videos only, you need to see through those videos and you can understand it more better, right? Yes, memoryless system I have already told you many a times. So for the case of memoryless system, what? For the case of memoryless system, it would be like if you see a question wherein after you substitute the value of t, you require a simplification, then you can say that those kinds of systems are not memoryless, but it might be causal or non-causal, because sometimes those does not depend upon the future values, because past values is considered for the causal system. You can say that those systems are causal, right, or non-causal depending upon the result that you get, that is output, right? Yes. So simplification in the sense, if you get, see here it is t minus 1. When you substitute the value of t, you need to do some simplification there and you get a different value. You don't retain the value of t. So therefore, for those kinds of system, you can directly say that it is a not memoryless system, right? I guess you understood that. And now let me move on to the same type of question. That is the second question. That is would be, that is d by dt of that is d by dt of, that is what I can say, e to the power of t into x of t, e to the power of minus t into x of t. So see here, let me do the analyzation with respect to the question itself first, and then let me move on to the simplification procedure. Okay, so now you can see that this d by dt question has been given in the last one also, right? So you can see that this d by dt can be multiplied to what? Can be multiplied to ax1 of t as well as, that is, ax of t as well as bx2 of t, and so therefore you can see that it would become the same. So therefore I can say that it is linear system. Like in the case of a single transformation of x1 of t and x2 of t, you get this d by dt of that e to the power of t into x1 of t and d by dt into e to the power of t into x1 of t. You get single transformation, right? So in the case of whole transformation, you need to make sure that you get the same single transformation result only, right? Yes, that is when you get, when this gets multiplied to ax1 of t as well as bx2 of t, right? The resultant that you get, right? Yes. So that is what I told you. So you have to understand those things. So that is why I told you, first analyze the question. First, what are the things present you see, then you can go to solve the problem, right? Yes. So for sometimes whatever the result in single transformation you get, that is a transformation of x1 of t plus b transformation of x2 of t. So the same thing you have to get it here itself. So that is when, so these kinds of things, that is multiplied with x of t, that should get multiplied to ax1 of t as well as bx2 of t, right? So if that gets multiplied, then you get the same result as single transformation itself, right? Yes. So now the second thing that I found out is there is another t over here, right? Another t, and this t is not associated with this x. And in the case of, that is whole transformation of x of t minus t naught, you don't consider this t, that is you don't subtract with minus t naught for this t. When you see y of t minus t naught, you just subtract with what? You just subtract with, that is your t minus t naught, that is t gets substituted with t minus t naught in the case of y of t minus t naught, and here also it becomes x of t minus t naught, and that result would be the difference. So therefore it is a time variant system. Here you get e to the power of minus t into x of t minus t naught, but there you get e to the power of minus t, that is minus t naught, that is t minus t naught the whole bracket, because this minus is associated with the t. So then t minus t naught also gets associated with this minus, right? So therefore this minus, that means this minus gets associated with t minus t naught. So you get a resultant like this, that is e of minus t plus t naught, that is x of t minus t naught. This is different, right? So this is a time variant system by easily you can say. So now the next thing for memoryless is, you can see that there is no substitution required, simplification required even after the substitution of, that is values of t here, right? You don't need any, what I can say, the substitutions is required. You should know first the basic thing that I have to substitute the values of values of t only for this x of t, not for any other t that is present, which is not associated with this x of x, right? So if you know that, you can easily solve the problem. Many people sometimes they don't study that much, like they don't even know that I need to only substitute the value of t, value for t which is associated with x, and they'll just go to the examination hall, and if they see another t over here, they think that, oh, for this t also I have to substitute, and no, it is not that. It is only for this t you need to make a substitution, that is the values of t starting from 0, 1, 2, 3 or minus 1, minus 2, minus 3, you need to make a substitution, right? Yes. So now there is no substitution, simplification required even after substitution. I can say that this system is memoryless as well as causal. And in the case of stability, you can say that it is unstable, right? Yes, this is causal system but not memoryless. So for not memoryless, you have to see the question number, that is last question, whatever we did, the same thing you have to do, because this is d by dt system, right? Yes. So now coming on to this question, now analyze the question clearly. What I told you first, I told that this d by dt is present wherein you can multiply to the whole transformation. So therefore this is linear, my first one. My second one is I found out another t which is not associated with this x, and I can say that that is a time variant system. Third one, what I told you. So third one, what I told was something, there was a glitch there. So for the case of third one, you can see that as this is d by dt system, so you can see that you can see that you have to follow the same procedure as per the last question we did, and it would be a not memoryless, but it would be a causal system, right? And it is an unstable system, right? So now I'll show you the textbook itself here. See, yes, here see it is same. So this is d by dt of e to the power of t, also you need to keep it outside, and here you can see that d by dt gets multiplied to this. So the resultant, my resultant would be what? My resultant would be, so this is a into d by dt of e to the power of t into x1 of t. So that is, you have to remove a and b as a a and b constant outside, and you have to multiply d by dt to this a to the power of t into x1 of t. And here also it is the same, that is d by dt, that is into e to the power of t, e to the power of minus t into x2 of t. So this same thing you get it over here, right? Yes. This is what? A into d by dt of e to the power of minus t into x1 of t. This is plus b into d by dt of e to the power of minus t into x2 of t. So therefore this is a transformation of x1 of t plus b transformation of x2 of t. You get the same result, and so therefore you can say that the system is linear, right? Time invariance, I told you that, see here you have another t, and I already explained you. So it is a time invariant system. And for not memoryless, the same thing what I explained you in the last problem, the same thing. The causal also the same, unstable is also the same, right? So this is what are the two questions that we learned for today's class, right? So in today's class we learned about differentiation, and in the case of differentiation you got to know how it is not memoryless, causal, and how it is linear. In the case of linear, d by dt got multiplied to the whole transformation equation, right? Yes. So that is what is, you can see that it is a, what I can say, linear system. In the case of time variant system, you can see time invariant system, you can see that there was no other t in the case of first one. It was only x of t that was present. So therefore for that x of t, you just substituted minus t naught and minus t naught. That is, you just subtracted with minus t naught, and for the t in the case of y of t minus t naught, you just substituted minus t naught, right? You just substituted what I can say, the minus t, the t minus t naught, right? Yes. And then for the case of not memoryless, what did you do? You just took a condition in the case of first one wherein y of t is equal to the same time period when your time period is, that is, greater than or equal to 0. If you substitute your time period as 3, if it is greater than or equal to 0, then your amplitude would be 3 itself, and it is 0 for t lesser than 0. And then you saw another question, that is one more, that is for the case of causal, you got to know that it's not depending upon future value, so therefore it is a causal system. So you took a condition for not memoryless and you told that the same condition. So if you consider your y of t, for y of t, if you substitute the value of t, you can see that for that value, particular value of t, you get it equal to 1 for the t that is greater than 0. So therefore it is not memoryless and it is a causal system, and the system is unstable. Why? Because when you applied u of t as an input to the system, you got, that is, 2 times of delta of t, that is delta of t into delta of t, that is a 2 units impulse function are multiplied. So therefore those that have unbounded amplitude, and so therefore I can say that it is an unstable system. Okay, so I guess you all got it how to do it. So I told you whatever the glitch was present in the third one, that is in the second question, I told you, right, it is like you need to follow the same question, that is d by dt of x of t question, whatever we did for memoryless and stability, you have to follow the same, right? I told you, right? Yes. So for causality also it is the same in the case of the d by dt of x of t as well as this particular question. Second question what we did, and this was time variant because we found out another t, that is a to the power of minus t, and the system was linear, right? Yes. So now I guess you got how to do these 2 questions, and we'll do more and more questions in further classes, and you can see that these 5 things you need to always remember before doing the problems, right? When you see the question itself, you can see that anything multiplied to x of t, anything multiplied to x of t, you need to make sure that those things, that is for example tx of t, that is those things what you can say that this should get multiplied to the whole transformation result, right? Multiplied to whole transformation result, right? Whole transformation in the sense that is transformation of ax1 of t plus bx2 of t. So that is, for that it should get multiplied. So if it does not get multiplied, so then it is non-linear, because in the case of single transformation, this get attached to x1 of t as well as x2 of t. But in the case of whole transformation, it becomes the, what I can say, it gets attached to the whole x1 of t as well as bx2 of t, which becomes different, right? And the second thing, in the case of time invariancy concept, so you need to make sure that the t which is not another t, if you get more than one t, so though those things are directly time invariant system, but that t should not be associated with x again, like you should not get again like x of t minus 1 or x of t minus 2 along with x of t. Right? If you get this kinds of question, then it is directly you can say that it is a time invariant system. But if t is present other than x of t, so therefore you can say that it is a time variant system, right? You can easily find it out, right? Yes. If you find another t which is associated with x only, then that t also should be considered for the whole transformation of x of t minus t naught. So those system does not become a time variant system, right? And in the case of memoryless, I already told you that when you substitute x of t values, when you substitute the values of t, when you substitute the values of t, values of t, you see that there will be some simplification required, right? If there is some simplification required even after substituting the value of t, so therefore, so for those questions you can see that it is a what? So it is a not memoryless system, right? Because when you substitute the value of t and if you do some simplification, so that simplification will yield a different value other than t. So therefore, for those kinds of question, you can directly say that they are not memoryless and they might be causal or not causal depending upon the output. That is, it should not depend upon future values for causal. If it depends, then it is non-causal. For stability, you need to study with respect to the problems itself. I told you, right? There is no cut short for stability. You need to study with respect to the problems itself. So, which problems provide bounded input and bounded output, right? So, this is what is for today's session, and let us meet in tomorrow's class. Thank you.